Imagine you are 250 miles above the surface of the Earth. There are only a few millimeters of material separating you from the vast emptiness of space. Suddenly you are alerted that a mission-critical system will fail in just a few hours if not repaired. And once it fails, you and the others on the station will only have another day to live unless you abandon the station.
Houston, we have a problem.
NASA and Made in Space Incorporated came up with not only a potential solution to issues like this in the future, but are expanding engineering knowledge literally out of this world. Resupplying the International Space Station not only takes months to prepare, it is very expensive per launch, between $115 and $225 million. So what happens if you need a part or a tool in a pinch? In 2014, NASA completed the certification test for and launched a 3D printer to the ISS in September of that year. The printer uses an additive manufacturing process and is a fused deposition modeling or FDM type of printer. Additive manufacturing is the process of joining materials to create an object from a 3D model, usually layer by layer. This is contrasted by subtractive manufacturing, which usually starts with a larger blank and machining or cutting material away, creating lots of waste. FDM, or fused deposition modeling, is the most common type of additive manufacturing and was first developed in 1988 by the co-founder of Stratasys Incorporated, which to this day builds industrial-grade 3D printers. While NASA wanted a solution to creating parts and tools on the ISS, they also wanted to explore the possibility of being able to use 3D printers in a zero-G or microgravity environment. Successful tests of the printer proved that we could expand a safer and cleaner manufacturing process not only to orbit around our world, but to other planets we chose to explore. Thank you for watching Pack Mule STEM Facts. Please like the video and subscribe to our channel for more.